to discuss the efficiency enhancement of perovskite tandem solar cell. We are utilizing non-toxic materials. Basic structure of a photovoltaic solar cell. A photovoltaic solar cell is made up of three main parts: light absorber, carrier collector, metal contacts. In the diagram, we can see the first part is glass cover, anti-reflection coating, front and back contact. In between, there is an absorber layer. The absorber layer is called as the heart of solar cell. Whenever sunlight enters, it generates holes and electrons, same like a PN junction diode, and we collect it by front and back contact. Three generation of solar cells: wafer based, thin aluminum, and dye synthesized. Monocrystalline, polycrystalline, and multi-junction. Approximately they have 25% efficiency, 20% polycrystalline, and multi-junction has 40%. Thin films have lower efficiency, that is 13%, 17%, and 20%. We need the low cost and high efficiency. For that, we went to the dye synthesized solar cell, quantum dot synthesized solar cell, organic photovoltaics, and polymer hybrid solar cells. In the new generation, we have perovskite tandem solar cells. If we see the evolution of solar cell, in the first generation we have inorganic wafer based, that is silicon, with efficiency of 26.7%. Second generation we have inorganic thin films, that is cadmium telluride. Then we, for easy processing we and low cost, we go for dye synthesized. But in the dye synthesized, it is very thin, but efficiency is not very good. Then we go for higher efficiency and lower cost, organic inorganic hybrid perovskite tandem solar cell, which is having higher efficiency. If you look at the single junction solar cell, it has an absorber layer and contacts. As the sunlight enters, it generates into electrons and hole pairs. Next, we have to see the efficiency limit of single junction solar cell. In single junction solar cell, the major issue is of thermalization losses. The electrons flow from valence to conduction band, but some of the charges from valence to conduction band do not have such an energy to go to the conduction band, and some of them having higher energy, so they surpass the conduction band. We have to find out the solution in between. For that, we have created multi-junction tandem solar cells. In multi-junction tandem solar cells, we have three contacts and we have two absorber layers. For smaller band gap, which the charge is having lower energy, can be absorbed in absorber number 2, which having small band gap, and the charges which is having higher energy is absorbed in the absorber layer 1, which having large band gap. This improves the efficiency and also the performance, and if the thermalization losses are reduced, the efficiency is definitely increased. This is abstract. In abstract, we have focused on two things, that is by taking the non-toxic element tin instead of lead. Lead, if consumed by the humans, are very dangerous, led to the kidney diseases and other diseases. Also, we have focused on the modifications of the following parameters, that is impact on the absorber layer, effect on the defect density absorber, impact on absorber band gap, influence on the operating temperature are done to obtain the maximum efficiency of proposed cell structure. If you see the introduction, there is a meteoric rise in perovskite tandem solar cell. These are excellent contenders for with facile fabrication. Also, they can surpass easily the Shockley-Queisser limit. Research is going on this perovskite tandem solar cells. The students who are doing the MTech and having great interest in the research can follow the perovskite tandem solar cell. Also, we can see the architecture of this solar cell. The front layer is called as fluorine tin oxide, second layer is called electron transport layer, and the fourth layer is called as hole transport layer, and then its contact is silver. In between, the absorber layer is called as a methyl ammonium tin bromide. Instead, we have taken tin instead of lead. Methodology. We can see the solar cell capacitance simulation known as SCAPS. This is the one of the software you can easily use, made by the Department of Electronics and Information System of the University of Ghent, Belgium. This is the one of the best software with the version 3.309. You can use this to add the experiments and find out different layers You can take different layers, fluorine tin oxide, or you can take any other layer, then you find out the solutions of that. Thank you very much.